So before we get into agents and Koog, can you tell us a bit about your backstory and how you ended up working on this?
Yeah, sure. So I actually joined JetBrains somewhat around almost 8 years ago. It was actually an internship. So I joined technically a Kotlin team, but I was actually doing a side project. So I was building a Java language analyzer with the distributed systems in using the Ktor model. So we've been using Akka at the time. And then after this project, which was pretty successful, rather research than something going to production, I joined the Kotlin IDE team, and I've been doing some IDE features there. Then I moved to Kotlin libraries. So I was working on the compiler plugin for software transactional memory for Kotlin native and Kotlin multi-platform. And after that, I joined the Ktor team right at the time it was created. So I was mainly responsible for the new Ktor IDE almost entirely, and also was helping with some framework functionality. So, for example, I'm the author of the what was called the new plugins API for the Ktor. So previously it was you had to implement some pipelines and all the stuff like that. And I created the simpler API with the DSL. So that was one of the things that I was doing there. And then after a few years with Ktor, I switched to Kadana in JetBrains. It's a static code analysis tool that you can run on the backend, and it would analyze your code and show some inspections. So I've been doing mainly the backend side of it. So I've been the part of Kadana Cloud, and we were using Ktor. So my experience was pretty much relevant there. And then eventually I ended up being here in what was called AI Agents Platform, powering all the JetBrains products that's gonna use AI and specifically AI agents. And then we basically renamed our team to Koog because we ended up doing the framework for any Kotlin developers who want to build agents. So, and here am I.
Okay, so it sounds like you've had a diverse experience in JetBrains, working on a lot of things, and I guess a lot of listeners have interacted with some of your work, whether it's some IDE feature or the plugins in Ktor, which sounds pretty fun. I think we can start moving towards the agent topic then, and just for those listening who are not that deep into the AI field yet, can we start with what an AI agent is before we get to the Kotlin specific bits?
Yes, of course. So basically, I pretty much love the Sebastian's answer to this question that he started with. So basically, it's a system that can use the LLMs and your environment, like your tools, your backend, your mobile phone, whatever it is, to solve the end user problem. So basically, it's like the brain, which is the LLM, and the tools from whatever you're building connected together and solving the final problem.
Okay. Yeah, but I like that a lot. Really, it's kind of it's such an interesting idea, right? Because you're kind of bringing in a thing that thinks or at least certainly makes decisions by itself and can use all of the individual components that you might have in your software system, however you expose them, which is it is kind of a game changer just in regards of what might be possible with it and the open-endedness of it. So now, like we said, we're talking about Koog here. So what's Koog and how does it fit into this whole agentic picture?
So Koog is the new open source framework. So it's relatively new. It was released a few months ago during the Kotlin Conf for building AI agents in Kotlin. And let me just give a little bit of hint here, because like what I mean by AI agents, I don't mean like the coding agents, because like there is a misconception that if you're building AI agents and it's a framework by JetBrains, it shouldn't mean that it's specifically for building the coding assistants or coding agents. It's for building any agents. So let me just like repeat it again. Like you can take whatever you are building and make it agentic. So that's what Koog is designed for. And specifically, it's targeting like Kotlin users, Android developers, backend developers, and JVM developers as well. So rather than building something like in Python, for example, for the sake of experiment, Koog is more targeting the enterprise side of things.
Okay, and I think we probably want to dive a little bit deeper into this, but it's a really good point to make early, that we're talking about a general purpose framework here. So that means that it can be integrated in all kinds of domains. Are there any specific like domains where you could see Koog becoming like popular in the near future?
Yes, for sure. So I think that there is a high potential, specifically because it's Kotlin, and a lot of people are using Kotlin for Android development. It's like it has a high potential of being the framework for Android agents that will be like running right in your phone and automating some tasks right there in any application. But on top of that, I still believe that backend is where most of the agents will be running at scale. And that's exactly where we want to also position Koog. So for example, it can be like, because like we did a market research, like what types of agents people are building, and even like what technologies they are using, what is like the main technologies in the company, and what is the technology chosen for the agent development. And when we talk about like the applications of the agents, I would say that one of the things that people are building agents for is obviously chatbots, like assistants, support assistants, or any other assistants. But another interesting area is internal automations, because like the area itself, the AI area itself is pretty young, and enterprises are rather conservative before like they implement something. They want to make sure that it's kind of working and not breaking the reputation. So for that reason, a lot of the enterprises, they are applying agents actively right now for automating their internal operations, like whether it's like ticket booking, or some help with accounting, or messages with internal chats, and many stuff like that. So that's a pretty huge area, and that can save a lot of time and money and allow the companies to focus on less routine tasks. Another area is basically embedded devices and embedded agents. So because like we talked with a few people from the community that are already building something with Koog, and I'm not going to mention the specific names, but you could imagine pretty large automotive manufacturers, like the companies that make cars, they are experimenting with building AI agents right in the car, and you can communicate with your car using your voice and ask it to do some like commands, open the window, or, enable the air conditioning, these kind of things. And there is like a lot happening with local models because of that, because, a lot of like many types of information, you don't just want to, send to some cloud. And Koog also allows you to basically solve this problem as well, because we were also focusing on the local model support as well. So I would say that, of course, there are like a lot of different applications for AI agents, including the, let's call it the imaginative UI or interactive UI. For example, like you can ask the LLM to generate the whole UI layer for you, depending on what you are doing. because like UI can be like described as a JSON, and you can just ask the LLM, I want to solve this problem. I'm this user. Here is like my information, and it will generate the right buttons, the right like text fields, and many other things that needs to be shown to this user to be comfortable solving this problem. So agents can work on the backend, automating some, enterprise level tasks, but they also can work on device, automating some like user level tasks. So I would say that the application is like very broad here.
Okay. All right. Well, when you were saying general purpose, you weren't kidding. That's a lot. Yeah. I mean, it's quite a broad target to hit, going from all the way from Android, like running on Android agents that are really on device, to going on automotive. I sure hope I won't have to like tell my agent like, hey, could you please brake? I hope that's gonna stay a pedal. But we never know where these things are going. On the back end, there's obviously seems to be a lot as well. And the whole creative UI or dynamic UI story is also one. Again, it sounds wonderfully visionary. Sounds like there's plenty of ideas that one might have. So I want to do the full U-turn now and dive into the nitty-gritty of what we have when we look at Koog. Like, what are the fundamental building blocks when I work with, like, when I start building an agent with Koog? What does that look like?
So basically, Koog splits the idea of AI agents into like a few components, which sound like pretty like reasonable if you think about that. So if you talk that agent is a autonomous system that solves the user problem interacting with LLM and with your device or with your environment, with your application. So we actually split it the natural way. So you have the environment level, which is the level of your tools, the functions from your application available to the LLM, to the agent, to solve the problem. So the other part is the LLM connection itself with all the configurations and model selection, parameters, and many other things. But then there is something in the middle that we call the agent strategy. So what is agent strategy? It's like the way your agent should interact with LLM and with your application to solve the problem. That might include, the steps that needs to be done. It's like an algorithm, but in a higher level way. So you don't have to like express it as the normal code, but Koog currently allows you to express it in the form of a graph, in form of a diagram that you would like kind of draw and imagine what steps have to be followed to solve the problem. And why I'm saying right now is because we are also experimenting with other approaches, and we have plans to provide the generic, more general format of like building strategies, but that's gonna be another topic for the discussion, I guess.
So, okay, let me, I wanted to ask two things at the same time. So these strategies, which you said that like define a graph of like how the agent works, can you tell us an example of maybe like a problem that you would solve in multiple steps, or what these different steps might be that a graph describes in an agent?
Yes, for sure. So let me start with like more personal example from the JetBrains experience. So basically, if you're building a coding agent that would do some coding tasks in your IDE or in other environment, you can basically provide all of the tools available, like refactoring, text editing, running the test, running the build, and many other things, right to the LLM, and then allow the LLM to call all of these tools to solve the user problem, to apply the user's request to this code. But if you start with this experiment and run it on somewhat larger than like a minimal MVP project, it's not going to work well. It's not going to be working reliable enough. And if you run it on a benchmark on SV bench, you're not going to see good results there. So for that reason, it makes a lot of sense to apply the human knowledge, like how you would approach this task as a developer, and combine the LLM logic in a smaller like building blocks. So for example, the first step could be preparing for the code generation. Like you gather the information, you create the folder structure, for example, you create the file structure and many other things, but you don't really apply it to your code base. And for that, you provide the model with a different task, like it's a prompt, a different set of tools for this specific task. And you don't tell the model that you're going to be like generating the code and verifying the code and running tests. You're only focusing the model on one specific area. And then the next step in this graph, in this algorithm, will be another autonomous block with an LLM, but with a focus on the code editing. You provide the model with like the tools for, changing the text of the file, applying some refactorings, and doing some other things like that. And the final block would be like the verification phase. It's where you make sure that the LLM actually runs the tests, it runs the build, it runs some static analysis or inspections. And then, guess what? You don't want to finish right there. You need to check, like do all the tests pass, do all the static analysis inspection pass. And if not, you can draw this like if you are thinking of it as a graph, you draw the edge backwards to the second phase and you tell the feedback to the LLM, these are the problems that have been identified and they need to be fixed. So that's a very high level view on this graph, but you can actually apply this idea to any generation problem, whether it's like a financial report generation or any other generation of whatever you're doing in your company. It shouldn't be like really applied only to the code.
So if we're thinking this through, like the similar strategy, like you said, for a financial report, it might be something like, well, you have like a data gathering phase in the beginning where you get things from, like you said, using the tools, which I think we'll need to dive into that a little bit more. But we'll get the data in somehow. We'll do some sort of processing with the LLM as the brain, where it maybe groups things under specific things or whatever, and then we forward this back into some sort of deterministic system that actually does like a compliance check. And if those compliance checks fails, like you just draw an edge backwards, you go back to the like classification phase, and you just kind of have this iterative loop until at the end, when everything passes, like you get out a perfectly compliant report at the end. Does that sound right?
Yes, I believe that could be an approach.
Yeah. So I guess the takeaway here is just like when you're giving an LLM like a single task, where the more you specify what you want in the output, the more precise it can be. Here, if you just break down a more complex flow that's already a known task, where you know what the steps should be roughly, and it's not something super general, then it helps the LLM to focus on one thing at a time. I also really like the feedback loop part of it, although I do wonder, like, is there a way for an agent to like get stuck in the loop where it tries something and it always fails verification? Like, is there something maybe in the framework for like, I don't know, maximum retries, or like how would that work?
Yes, exactly. So in the framework, on the level of agent configuration, Koog provides you with a maximum iterations parameter, which would regulate exactly that. And also there are like other techniques that you can apply right in your strategy, for example. So you can check specific information right there, or you can make the conditions of your own and make sure that the agent exits. And other than that, of course, Koog has all the checks that would verify that the finish is reachable in the graph. And we are also planning to add much more IDE support to help you building the reliable strategies of agents with Koog.
I like that the metaphor kind of this graph, it really does resonate with me, because I feel it would be the same thing that I would just provide somebody with if I wanted to explain them how to do a well-defined process, right? Like if I were just to write down how I would write the financial report, it would probably be a very similar thing, with me just pulling things together, verifying it, and iterating until I hit something. So for these cases, it really does seem like it's a really expressive way of doing this.
Yeah, when it comes to strategies, I'm wondering, is it always a different strategy for the specific task you want to implement for the agent? Or are there built-in flows that I can reuse? Maybe if I'm doing something simple, which doesn't require so much customization?
Yeah, so that's one of the things that actually Koog shines in, because we are basically building this framework to help the internal developers not to write AI. We want them to focus on building their IDEs, or UTrack or TeamCity or whatever other systems they are building, right? And that's why we actually run and test a lot of different strategies for a lot of different tasks, and even on the benchmarks. And then whatever remains successful, whatever building blocks actually solve the actual problem and perform better, they eventually are being left inside the framework, available for everyone. So of course, you can run simple strategies out of the box without implementing and even knowing about the fact that strategy exists. So the default strategy will be this agentic loop, like the LLM calling tools in a loop until the task is solved. So it's just there and you don't have to modify anything. Also, we have React strategy out of the box. So React stands for the reasoning and acting. It's where the LLM, after every n steps, does the acknowledgement of what it has been doing, or some reasoning step, and then continues solving the task. And also we have lower level building blocks for specific problems that you might face during the strategy development. But we're going to talk about it, I guess, a bit later.
So we've been talking a lot about graphs and transitioning between states and so on. So now the obvious question is, I'm a Kotlin developer. How do I express the graph in Koog?
Yeah, so Koog, because it's written specifically in Kotlin, takes advantage of the Kotlin DSL capabilities. And that's all about the Koog. So basically you can build this graph in a very concise and nice Kotlin DSL that would be easy to write if you're a Kotlin developer. And on top of that, it will be easy to read if you don't know Kotlin at all. So one of the benefits is that if you show this graph, the strategy of your agent, to your ML colleague, like to a researcher or machine learner engineer, they will be able to analyze what's happening just by looking at the DSL. And they would be able to advise you with some steps that you're going to be making to improve your agent.
Very cool. That's quite exciting. So then that means that I express this in form of I define a bunch of nodes using just Kotlin statements, and then I define a bunch of edges and just I just wire them together that way.
Yes, exactly. So Koog provides you the node DSL, the edges DSL, and the condition DSL. And on top of that, you can also build subgraphs. And also you can combine multiple agents between each other altogether. And that has another advantage, actually, if you want to evaluate your agent, all these steps, all these nodes and edges will be present in the tracing, in the OpenTelemetry tracing. If you observe what's happening in your agent, it will give you a high level insight, what was happening, what prompts, what message history did you have, and why the agent decided to behave this way but not the other way. And on top of that, this graph structure has one more advantage. So it allows you to persist the state of your agent, because graph is essentially a state machine, right? And you fully control what's happening in the state machine. But moreover, you can persist the whole state. If something is failing, imagine that like you're a AWS developer running the agent somewhere on your server, and because of you're using the spot instance, which is cheaper than normal instance, there is no guarantee it's not going to be preempted, and likely it will be at some point. And with agents, because agents are like the longer running tasks, it's easily possible that they're going to be stopped and crashed because of this situation in the middle of the execution. And if you enable the persistency with graphs, you will be able to store the whole pointer, the whole state machine, the whole thing that we call the situation that happened to your agent, including not only the chat history, but also the place in the graph where you are. So that the next time when you run your agent again on another machine, you will be able to restore the whole state from the exact point of execution. And that's actually one of the core advantages of the graph, because they allow you to build scalable and fault-tolerant system, not just some systems with agents.
Very cool. Very cool. I just want to clear up this one little side note, because I'm not sure if everybody knows what an AWS Spot instance is. Those are VMs that are sold to you at a much lower cost, but in exchange for that, Amazon can just take them away from you at essentially any point, right? And that's kind of the bargain that you strike. On the one hand, you essentially get to use unused AWS capacity at really, really cheap prices, but you don't know for how long, because there might be some other hyperscaler next door who's willing to pay a lot more, and then they'll just grab those back for you. So for those kind of scenarios, I mean, it sounds great. Sorry, that was a complete aside. Marton, please.
Yeah, I also really like the idea of an agent being able to persist its state and then continue. So I guess this could be used for a real life flow where by definition it takes maybe a couple of days for something to happen. So maybe data needs to make its way somewhere. Maybe you need to mail something to the user as authentication, and they need to enter it back into the system, or whatever it might be. Someone has to visit a physical location. And it's kind of cool that you could define a long-running flow, still managed by the agent, but that it would be able to basically wait out these kinds of delays. You're not spinning a function, but you can just recover it and resume it later.
I mean, we've had coroutines with short-term delays and asynchronicity, but a couple of days or a month until someone comes back. That's a pretty nifty upgrade on the persistence layer. I love that.
Yeah. You've also mentioned subgraphs here. So I'm wondering what scenario you would want to use one of those. Is that for reusing some logic that you have in your application that you need in multiple places, or?
Yes. So basically, because everything is being pluggable, you can build some generic components like a subgraph that solves some class of the problems. And then you can, because it's a DSL, and you can just define your graph as a Kotlin extension function that can be reused in multiple places. And then you can wire up these subgraphs one after each other with different tasks or different configuration parameters. And while I was describing the coding agent, or when Sebastian gave an example of the similar financial report generator agent, this was actually essentially a subgraphs. So all the steps, all the autonomous blocks that have different tasks, different tools, different configuration parameters, wire one after each other, are essentially subgraphs. So Koog allows you to operate on a lower level with a primitive nodes, which can be basically any Kotlin code. So a node is any Kotlin code that takes some input and produces some output in a typed way. And you can wire up one node after each other if they are kind of compatible in terms of types, which is another advantage of using Kotlin for such type of development. And also we have pre-built lower level nodes, such as, calling LLM, calling the tool from your environment, from your application, and many other different out-of-the-box nodes. But then if you go like higher level, if you already implement this basic agent loop, you can form subgraphs that can be reused on like multiple different levels. And then you can use like, subgraphs of the subgraphs and so on, depending on how complex your use case is. Does that make sense?
Yeah. So I could imagine like I have a subgraph for like get me the user's, email address. And then this could involve like signing them up if they don't have an account already, or it could fetch it from like different places if they use a social login. So I can imagine it could have a bunch of different like complex logic. And once I have this, like, of course I would want to reuse it everywhere where I just need their email for the next step. So you've mentioned that in nodes, you can just write arbitrary Kotlin code as the implementation of a node as you're going through the different steps. And I can see how I could call into my existing code there. So if I have services, databases, I could access them, I could work with them. But we also have this notion of tools where the agent can choose to use a tool, and I'm supposed to be able to connect to my existing code base there as well. So like, how can an agent invoke my code and communicate with it? What does that look like in Kotlin code?
Yeah, sure. So depending on the application, so if you as a strategy developer know that specifically you need to do, email sending here, you can just do that from your node by directly invoking this from your Kotlin code. But if you don't know like what to do to solve the task, you just throw it to the LLM, give the tools to the LLM from your application. It can be just like, 5 tools or 10 tools from your application. And then the user or you as a developer prompt the LLM, just, please solve this task. I want to be, helping this user with whatever task they are solving. And the LLM would become a brain, and LLM would decide that, well, the email sending is required for this step. And all LLM providers, they have the API for that. So of course, essentially tool calling is a text messaging between the LLM and your application. So imagine that you can, ask the LLM to output a JSON that would describe the function signature that it wants to call. But of course, it's a bit more high level, and in terms of REST API that all LLM providers have, it's like a separate thing that LLMs are trained to do. So LLMs are aware of the tools and of the tool format, and they are trained to follow the specific signature of the functions provided to them. So of course, things happen, but most of the time, there is no way LLM would make a mistake here. So you can basically rely on all of this functionality of the LLM itself. And Koog as a framework provides the orchestration level on top. So you can just take any function in your code, annotate it with just one word, add tool, and provide it to the LLM. And then all the magic would happen. So Koog will generate all the JSON schemas, description for the parameters, and many other things so that LLM would know like what is available. And then depending on the task that the user asked the agent to do, LLM would decide that, well, I need to call this function. And Koog will handle all the orchestration logic, suspend function calling, and many other things.
Got it. So I define my functions. I annotate them with tool. I feed that into Koog, which will teach the LLM how to call it. And then whenever the LLM feels like it needs the functionality that's in the given method that I've annotated, it sends this like standard format message, which Koog again parses back and like actually calls into my method. I guess it basically just like has an ID or something that Koog generates in the background, and then the LLM calls the method by ID or something like that.
Well, there is no such ID, but basically the format that LLM expects from you as a agent developer is the tool has a name, the tool has a description, which is basically the text describing what the function is doing. Pretty similar to, you're writing a documentation like KDoc for your fellow developer colleagues to explain like what is the meaning of the function. It's very similar to that. And then you have like a list of parameters which have like the name, the description, and the type. And that's basically it. You can easily imagine how it would look in the JSON format. And it's basically being sent to the LLM as the list of available functions. And then whenever LLM decides to call the tool or a list of tool at the same time, it will just produce the list of JSONs with the same format, but also with the parameter values. For example, like if you have the tool like send email with a parameter text and a parameter username, the LLM will basically form a JSON send email username equals Martin and text equals hello. And then it's the responsibility of the framework to basically parse this information, find the available functions from the ones provided in your application, and execute them.
Yeah, very nice. So it sounds like Koog in this case is doing a lot of this like translation and like manual, like boring serialization work that I would have to do if I was directly talking to the LLM. Is this like Kotlin X serialization? Like, do I have to be careful about my parameter types of like not using custom objects or providing serializers for them? Like, can LLMs work with things like that?
Yeah, so we are relying on the Kotlin X serialization right now. But also there is a way for you to define a tool in a form of a class, which has the execute method, and it has the tool descriptor parameter that you need to override by yourself. So basically, it's a very similar thing, but you will have to describe the tool by yourself. But it fits some more complex scenarios if something couldn't be serialized, but as a developer, you know better how to do that. Or also it works well for the case when the JSON format doesn't work as good and you want to describe some tools in a different way.
Picking Kotlin X serialization, I guess, also does make sense since you've mentioned that I can run Koog on like on Android on backend, and so it makes sense that you'd also want to have a framework that already maybe puts you into the realm of multi-platform. The multi-platform story we can maybe also talk about just in a little bit. While we're still on the subject of tools, the other big thing that always comes up in the story of tool calling is MCP, right? The Model Context Protocol, which I'm not sure if we've touched on. I think we've maybe briefly touched on this with Alex in one of the previous episodes. But it's like a standardized way, right, of communicating. A standard that was originally, I think, made by Anthropic and is now just like an open standard. We also do have the official like client and server SDKs for MCP for Kotlin just in general. But since it is a format for specifying tools, it sounds like it would also be something that the Koog would probably interface with, right? So is there just built-in support?
Yes, there is. So Koog supports MCP tools, but I would maybe put some distinguishment here. So the tools from your application that the agent is running on don't have to be defined as MCP tools because they are just there. But MCP is better for the scenario when you want to call some external tools from external application or externally running server, for example, like Google Maps. And you would easily connect that to your application through the MCP and provide to the agent running right on your device or on your server. And by the way, just to mention, like since the latest release, the official Kotlin SDK for MCP is also supported by the Koog team. So we are the maintainers of that one as well right now.
Okay, that's awesome. So one more question about this. If I'm building an agent in Koog, can I turn that into something that's then exposed via MCP for other systems to interact with? Is that an option?
Yes. So there is an option always to expose your agent as a tool. And you can do that like locally. So Koog provides the simple DSL like function for that. Like you can say agent.astool, and it will be a tool now.
Okay.
Yeah. And also you can do that through the MCP server as well by yourself. Other than that, there is a different protocol for that scenario, which is called A2A, released a bit more recently than MCP by Google. And it allows you to have more precise agent-to-agent communication. So agent would know about the running processes of the other agents, and they would not treat each other as tools. And we are actually actively working on supporting A2A in Koog as well for the multi-platform.
Okay. Very, very cool. I have to say I'm very impressed by the, like, I don't know what the right word is. Maybe it's not modularity, but the fact that composability, I suppose, is the word. We love compose on this show. Like the idea of like, hey, you have a like small like self-contained workflow, you can turn it into a subgraph. You have like a self-contained agent, you can turn it into a tool for another agent to use. Like it's agentic solutions all the way down, and like being able to express all of that in Kotlin is kind of cool. Like again, like also just like, you know, slapping on an annotation and turning it just a regular Kotlin function into a thing that an LLM can use, or that an agent can use. That's really awesome. There's so much more I wanna talk about, but there is maybe just one, like, so like what's the actual entry point look like? What, like, is it just do I just get an agent object? Just like what does that look like?
Yeah, the most basic entry point is you just add the Koog all-in-one dependency. So we have like multiple dependencies on the Maven local, Maven central. But of course, there is the all-in-one option for the simple trial usage. So you add that, and then you create the instance of what we call AI agent, provide it with prompts, provide it with the LLM connection, which is a client to either Anthropic or Google or all of them, or maybe Ollama, depending on like your choice. And then you provide it with a set of tools from your application, which can be also an empty set. And then you call the agent.run. And that's basically it. So it's exactly like 5 lines of code that you need to write to have the basic agent and connect it with your application.
That's really incredible. So then, like, the run, it just it takes some input and it returns some output. That's it.
Yeah, exactly.
That's, again, like, I love this because it really links up with this whole idea of like composability, because now I can just think, like, if I'm building a larger system, I can just think of my agent as just another function, right? Like it's just another thing that takes some input but returns some output, which is really cool. Is it always like a function that takes a string and returns a string?
In the basic scenario, yes. But in the general scenario, you can build any agents of any types. And they're also composable. So you can imagine a strategy of the agent that would take a data class and produce the image. That could be also possible.
All right, so it's like even from the interface perspective, that's really cool, because I think the mental model, at least for me, when like working with LLMs or playing with it like by myself, it was always like, well, it's a string, it returns a string. But the fact that Koog kind of gives you this like higher level of abstraction where it's like, listen, we'll manage the LLM history, you express a graph, we'll manage the graph states, but you know, if there's if you're changing types, then we can also return different types. That's extremely cool. But does that also mean that the graph itself is type safe?
Yes, that's the whole idea of it.
Oh,
so
okay.
Instead of like having the Python approach when you have the string to any map written in one file representing the whole state of your application, in Kotlin, you can do much better than that. You can express like all the nodes as type-safe function that has specific input and specific output. And you can only match the compatible nodes one after each other. Or Koog also allows you to transform one type into another type if they're not compatible. So you as a developer have a hint what to do and how to build your flow in a typed way without making like really silly mistake.
So it's really just like, sorry.
That makes a lot of sense, and it's a super nice, like a very Kotlin experience, like fundamentally, that you get that kind of type safety. I love hearing that.
It's incredible. It like, again, if the part that I love here the most is that we're saying it's graphs and it's type safe, which to me it's very well, my brain immediately conjures the idea just of Lego. Like you just have like things clicking together where they're supposed to, and if if you're holding it wrong, or if you're trying to attach things in it upside down where like it's incompatible, it's gonna tell you it's not gonna work. You're not gonna find out like on the 300th edge case in production. You're gonna see it right away. So you're building well-formed type safe systems where even the input and output types of the entire agent are controllable. I'm very excited. This is genuinely like this makes me very happy. To my audio listeners, I'm smiling. I'm just sitting here smiling, to be honest.
Yeah, if you think of it, it's like playing a Lego game or a puzzle.
Yeah.
So you're combining the pieces of Lego together if they are compatible, if they have the same color.
Yeah, and with all this like composability and agents and different protocols that different components might be speaking, you are likely to be building complex systems here, but you still have a lot of safety with like the type system guaranteeing that at least the things that you're lining up match up on the type level. So it's of course like pretty likely to actually work in production after that. We talked about like how you can launch Koog and you can basically like pass in a string and get a string out of it. I guess a lot of the time you would want to host it as part of an existing service. So like if you have a Ktor or a Spring application, the way that you would do this is just call into Koog as part of one of your endpoint implementations?
That could be an option, but on top of that, Koog provides the out-of-the-box support of Spring since the latest release. And in the upcoming one, so maybe by the time this video comes out, it will be already the latest release. Again, we made the Ktor plugin, the Ktor Koog plugin or Koog Ktor plugin, not sure how to call that because Koog also has the similar concept of plugins or features similar to the Ktor system. And basically we have a Koog plugin for Ktor that you can install, you can configure on like the entry point level, how you would connect to LLMs, to which LLMs you want to connect, what are the tokens, the credentials, the parameters. You install it to Ktor, and then from inside the Ktor roots, you can call Koog agents or LLMs right from there, and even respond this with the information from the LLM to the user. And we have a similar support for the Spring framework. We have Spring Boot support. And basically, it's similar to the idea that basically all the Spring beans become like Koog tools.
That sounds fantastic. That sounds super convenient. You've mentioned setting up the LLM provider a couple times now. Do we pretty much just get to use any LLM as the brain of an agent in Koog? As we're recording this, GPT-5 just came out. Like, could I already be running Koog using GPT-5, or how does that work?
Yeah, so you can use any LLM with Koog. So the basic interface allows you to even deploy your own LLM there. You just implement a few functions like how to connect to it, and it works. And also we provide the OpenAI, Anthropic, Google, Ollama, Bedrock, Azure, DeepSeek, and many others out of the box. And also all the models are basically interfaces that's even, in the recently released version of Koog, something is not there. You can implement the model, which is just a few fields, and you can easily have the specific model that is now available, like from yesterday.
Very nice. I have to say one of the things that makes me the happiest about this is the open router support. Because when I'm playing around or I'm building something new, I want to try a bunch of like different models, also from different providers, and I don't want to manage like 6 different API keys and tokens. And I'm also a little like, sometimes I'm not really sure how their billing works, like all these kind of things. I don't want to get into like an AWS situation where I accidentally like run my agent and then I'm out like $20,000 or something. So like the integration with Open Router is really powerful there, because on Open Router you put like $20 on your account and they just kind of route your requests to whatever LLM you want, right? Like you can do GPT-5, you can do like Claude Opus, you can do like one of the like super tiny models, like the recently released open source models from ChatGPT that like really zoom away with a lot of throughput, not as smart but very, very fast. You can just do kind of whatever, and you never run the risk of like overcharging your credit card or that either, which is really nice. So having that out of the box, like when I was playing with Koog for a little bit earlier, I was like, it's good thinking. It makes the life of someone wanting to experiment with easier. And in fact, I wanted to get Martin on the Koog train as well already ahead of things. And one of the cool things that you can do is you can create an API key with a max spend. So you can just create an API key and be like, here's an API key. You can use it for $2. Like, go nuts. And once you're done, like, you have to figure it out. Not my problem. But you can do it in a very like a very safe manner, like especially in experimentation. And that's super, super cool.
Yeah, no, you can also try different models for the different subtasks in your graph. So for example, like some models are the cheapest and you want to do some, let's say, not so responsible tasks as fast and as cheap as possible. But for some other tasks, you would need some other model that you have subscription for, and you are willing to pay for that. And you can easily switch, keeping the same conversation history, the same tool calling history. You easily switch to a different model, and especially it's like even more easier using Open Router because you have just one token. But if you have like multiple tokens and you use multiple providers, that's also possible and easy to do with Koog. And you can switch to another model and spawn another task, continue from the same place of the conversation using a different model.
That's really, really exciting. That's so cool.
That's very nice. Yeah, I can see how you would want to optimize for cost or for speed when you're doing something simple. Like, I just need to, I don't know, like the user has created an entry in my application and I need a automatically generated title for it, which seems like probably like a very cheap task. But then for like deep analysis, you would want to use something more serious. I'm actually wondering about how does the history transfer across these different steps? So like, when can you just assume that the next step knows the things that happened in previous steps, or how does that work when you're building with Koog?
Yeah, exactly. So that's one of the things that we decided to take fully to the part of the framework. So you don't have to manage how the history management works, because the framework just keeps track of all the actions. Of course, there are some tweaks that allow you to modify that behavior, but in general, the main idea that we had in mind is like you looking at the ChatGPT window. I'm pretty sure that most of the listeners are familiar with ChatGPT window. And basically, you are getting the latest response to your latest message, and then you're writing the next question. But the window itself keeps track of the history. You don't have to look through the history by yourself as a user. You don't have to like open another window and copy the history to that. Everything happens automatically there. And Koog basically takes this idea to the framework level, and you only wire up the inputs and outputs. Of course, you have the access to the history. Of course, you can modify the history at any time, and Koog provides you like a bunch of very complex working solutions to like retrieve facts from there, compress the history, and many other things. But in the simplest scenario, you don't have to really think and care about that. Everything happens out of the box, right there, somewhere on the background.
And this history would be per request that the agent receives, or can like something be maybe like shared between multiple requests? Like, is there some caching layer somewhere in the mix here?
Yeah, we have two features in Koog that you can install and apply to your agent, and they will take care of these situations. So one of them is the agent memory. So it allows you as a developer to think beforehand about the specific facts that are relevant for the other runs of the same agent, or even for the other users, or even for the other agents solving like some different tasks, but some information can be like reused across the same organization. So it provides the layers of abstraction to control this kind of information and extract that from the history and save to any storage like S3 or a database, and then load these facts even in another agent or another execution of the same agent. And also we have this persistency feature that I touched a little bit when talking about the AWS spot instances example. So basically, persistency feature allows you to store specific checkpoints and then go back to these checkpoints in the future. So you can do that like manually, or you can do that automatically as well.
Awesome. So one of the other topics that we wanted to talk about in regards to Koog is that we say it's for, like you say, it targets enterprises. You say it's for scaling your like agentic integrations. What does Koog do in this specific direction that helps with this?
Yeah, so one of the things is basically is the JVM framework, the obvious answer. So usually most of the enterprise code are being written in the JVM. And also Koog tends to integrate with the popular backend frameworks such as Spring or Ktor, for example, and we want to do even more integrations. We have integration with AWS Bedrock for the LLM scenario. And also we have all these controllability persistency features embedded into the Koog system. And we are actually looking also a lot towards the governance and moderation. For example, we added the moderation support recently because for the enterprises, it makes a lot of sense to be able to moderate the conversations in order not to have any legal problems. And Koog also wants to embrace this possibility and explore whenever something new pops up in this area. And also we are integrating with a lot of observability providers. For example, we are integrating with 1DB. We have a plan for the integration with the Dynatrace, which is probably the most popular observability tools for the enterprise world. Also Langfuse and many others. So we want to be the system that is integrating with most of the popular frameworks for the enterprise.
Okay. Yeah. And I guess especially the observability story and like being able to see what's going on is just something that's like really important for enterprises, right?
Yeah, for sure. And that's also very important for us in JetBrains, because again, we started as the internal framework initially. And it was like really one of the most important things for us internally, to be able to like test your agent, evaluate your agent, and understand what's happening in your agent.
Very, very nice. One of the other parts, especially when you're saying like you're building very complex things, as far as I know, the longer my context grows, I'm getting charged by the token. So things can get, well, not expensive, but it's very interesting, like having 200 one-shot conversations, like, question and response, versus having one conversation that takes 200 turns is like an order of magnitude more expensive, like at the least. So is Koog doing anything in this regard also to just kind of help you with this? Because like obviously you could just fire out like multiple things, but maybe there's like information in my context that I don't really need anymore, that's no longer relevant.
Yes, Koog provides the history compression techniques out of the box. And this is one of the things that is, in my understanding, in my knowledge, not present in any other frameworks out there. So it was built for our products specifically, because coding agents, let's be honest, these days coding agents are one of the most developed area in AI agent development, because there is a strong competition, there is a clear benchmark, and a clear definition of done. And because of that, coding agents, like people are building them like all the time, and they are one of the most long-running and computationally expensive AI agents out there, because they are like running your code, they are building your code, and if you're working with a large project, that's going to take a lot of terms, and that's going to burn a lot of money. And while optimizing for this use case internally, we came up with a few experiments and a few solutions. And then our machine learning colleagues, they helped us to evaluate all of the possibilities, fix different problems, and figure out what works the best. So Koog provides you the way to compress the history, which will save you tokens and also drastically increase the quality. Like in the benchmark, for example, if you compress the history between different logical steps, it could increase the quality up to like 15%, which is a lot, right? And I'm not even talking about the situation with Ollama. For example, Ollama will probably break if you reach the limits of the context window. It will not be able to continue the conversation. So some other providers, depending on the model, they would rather like shrink the context by themselves, just like keeping the last messages. But inevitably, it will bring you to the enormous spendings and lower quality of your agent. And Koog provides you the way to compress the history and a bunch of strategies that are working and proven and fine-tuned. So when I say strategies, I mean we have the fine-tuned prompts and the fine-tuned LLM algorithms that would extract the facts from your history reliably. And when I'm saying reliably, I mean they are tested on the real benchmarks, solving like real problems that we have been facing. And they are just out there. You declaratively can use like one of the strategies, and that will be able to like compress the history and pick up the right facts for the conversation.
So how does that work under? Sorry.
It is quite interesting that by compressing things and removing some of the data, you can get better quality. Like from one angle, you would expect that the more data the system has to work with, the better results it's going to produce, right? But I guess it's also a matter of like signal versus noise, so that you can remove the things that the LLM shouldn't be processing anymore, and you can you can find the important bits in there, which is very interesting and not at all intuitive for everyone, I think.
If you take a look at this from a different perspective, like imagine that you are treating each request as the new one, and in order to come up with the next action, with the next solution, as an LLM, you have to like read the whole conversation before. It's like you're looking at the large, quantum physics book, and you need to answer like one simple question. You have to read the book before answering the question. So instead of that, just like, give me the right page with a paragraph that answers this question, and that's it, right? So that's very similar to the idea of the history compression.
So how does this work, like under the hood? Like you're just taking like the entire conversation and you're like firing it back to the same model that you've been using for the rest of the conversation, like as an aside, and being like, hey, real quick, like what's the most important stuff in here? Like just give me like a summary, like in whatever like output format is good, and then you just do a swap, like you just like put that in like for the other conversation.
That's one of the history compression strategies that actually exists in Koog, and that's the simplest one, the default option. So it basically asks the model to provide the TLDR, what has been done so far, and then swaps the whole conversation. So basically it starts the new chat with a new conversation. But of course, it doesn't really work well for the more complex tasks. For example, it doesn't really work well for the code generation, because you would lose the essential information such as the open files, the specific like modules, dependencies. And the next time you would continue the task, the model will have to like search for all of this information again. So another approach that we tried was like the chunking of the history into like smaller pieces and compressing each of them independently, which worked way better, but still tended to lose important information for the more generic tasks. And then we came up with the fact retrieval strategy, which allow you as a developer to specify like, I need the file dependencies, module dependencies. I need like important files. I need something else like code style. And then LLM will search for each of them independently and provide a list of facts. And then only these facts, together with like some tricky prompts created by our brilliant machine learning colleagues, they will be the only things that will be remained in the conversation.
Yeah, makes a lot of sense. Again, like one of the cases where if you can provide more specific instructions and if you know the process that the agent should be performing, then you can also get like better result and use the less generic and more precise strategies.
I'm very surprised by the like sophistication that goes into this, because like OpenRouter has like history compression, which they, and I guess both because it's a fact and because it's a loving reference to Silicon Valley, they call middle out compression, which essentially just means if you're hitting the top like level of the context window, like if you're about to exceed it, the part that they keep is like the very first message, and then they'll just start dropping messages in the middle, because most likely the message in the beginning has a bunch of important instructions. The middle stuff is like intermediate steps, so it's not as important. And then, of course, like the last messages are probably the most relevant. But like you said, having something more sophisticated, something that also doesn't have to bump the entire context window, which is like 200,000, 400,000 tokens for some of these models now. And again, you're paying by the token, and they're not that cheap, especially the ones with the big context windows. Having the ability to do something there is a lot. Like having that integrated into the framework is really, really cool. I am just wondering, like, could I use like another LLM just for the summary process?
Yes, of course. So you can switch the LLM anytime you want, and then you can switch back.
Ah, that's so cool. And I guess so I can just express that in the graph as just being like this subgraph where I'll be doing some history compression. I want this running with a different LLM in context.
Well, if I remember it correctly, for this specific task, because it was already requested by someone of our users, we already provided this parameter.
Oh, perfect. Even better. Incredible stuff. Nice.
Now I'm starting to wonder if I can have an LLM monitoring the entire flow and deciding when to switch the executing LLM over time as different steps happen. But maybe that's still an engineering challenge for us to decide based on what we see in the results. One of the things that I've seen as I was looking at the documentation and samples here and there is that there's a bunch of things around Koog APIs that use Markdown. So like there's a dedicated API to input things as Markdown into an agent or something like that. So my question is basically like, what's the deal with the Markdown, and why is that important for working with agents?
Oh yeah, because like everyone likes Markdown, don't you? I'm kidding.
I mean, yes, but
yeah, actually there is a reason for that, and it's like really surprising and funny. But if you think of it, it could be like much more logical. When we were using prompts without Markdown, we had like specific like result on the benchmark. But then, while developing this SV agent and we switched all the prompts to Markdown format, we got like 2 or 3% increase in quality without changing anything else. Just imagine, right? And the explanation for that is basically there are like a lot of structured Markdown documents in the web. And most of the even like README files are written in Markdown. And on top of that, LLMs are trained to like treat every text as a chain of like the next line prediction, like the next token prediction. And Markdown, because of its structure, because the way it's like written, has exactly like that kind of formats. Because like in order to understand where you are in the document, you need to just read a few lines above, like the level of the header, for example, like it's like the level 2 header or the level 3 header, then a few lines before, and then you understand where you are in the document. And that works really well because of that's the way the LLM was trained.
Okay, so I guess it's just an extra level of guidance, like a bit of help for the LLM to just follow where it is as it's reading and processing things. That's very interesting and very funny. Like next time I'm prompting an agent, I'll have to think about formatting it with a couple headers, or when I'm telling it to like never do something, maybe like instead of all caps, I need to bold it with Markdown formatting.
Yeah.
Oh, that might actually help. Well, would you look at the time? We're coming up on. Well, it's so good that we don't have an actual limit. Because again, I'm happy that we can just keep talking. But I do think it's been a lot of chatting. So just quickly, what's coming up next for Koog? What plans are there for the framework, for the tooling? Like, is there a longer term like the goal that Koog wants to achieve? What's happened there?
Yeah, the ultimate goal for us is to be the number one framework for the Kotlin and for the JVM communities to build the agents, especially for the enterprise. And not only agents, but any AI systems. So we want to cover the whole life cycle of the AI development, including the lower level LM connections, RAG algorithms, database connections, and all that stuff. Then building on top of that the agentic level, and then ready to use strategies and approaches that could like serve as a library that anyone can select from and use in their system. And we also want to cover, we don't want to focus on like one single paradigm of writing AI agents. So currently, obviously, we have the graph paradigm, which has its own advantages that we discussed today. And we also have the out-of-the-box like simple agent or like React agent, which is basically similar to like most of the Python frameworks out there that you can find. They only allow you to like wire up like one simple agent, provide with tools, maybe connect them together, and that's it. So we have this like two very polar things, right? The simple approach and the complex graph approach. But then there is the whole spectrum in the middle that we want to cover. So for example, pretty soon we're going to release the non-graph API, which will persist most of the Koog features that you will be able to use with just plain Kotlin code. And that's going to be just like another implementation of the strategy interface that Koog has. So you just like implement the strategy with Kotlin code using a non-graph DSL. That's going to be working best for the experimentation or simpler use cases when you don't need the graphs, but you are not happy with the default agent. And another things that we are looking into is the planning strategies that we're going to include out of the box. And there is like a bunch of different types of planning strategies, both LLM-based and non-LLM based. And we're going to also allow you to select from a bunch of those. And in terms of tooling, we want Koog to be probably like the tooling first framework. I mean, supported fully in the IDE, especially in the JetBrains IDE. And we are heavily working in that direction. And pretty soon we're going to release the first version of the AI debugger that is currently available for Python only, for PyCharm. We're going to release one for Koog for IntelliJ. And then on top of that, we are building a lot of the IDE support, including like Wizard, visually building the agents using the no-code building blocks. Like you can draw the graph, you can imagine how it would work, right? With all the AI support, completions, inspections, and even some tooling that would analyze your agent over time and allow you to make the decisions in the future, how to improve it. So there is a lot of things happening there, and you're going to hear much more even further.
Very cool. So as we wrap up, I guess it's important to emphasize again that all of this is open source, so people can pick it up and try it already and then play with it, and we really encourage them to do so. There's supposed to be, looking at our notes, there's supposed to be a story here about how it became open source. Can you tell us a bit about that?
Yeah, that's actually a very interesting story because initially Koog started as the internal library helping internal JetBrains products to build their AI agents in the products. But then eventually at some point we decided that, well, actually there is no reason to keep that in secret. We can basically share it with the whole community. And then there was also the Kotlin Conf approaching, and we decided, well, let's connect these two facts together and open source it, right? And it was actually a tough work happening because internally we were using a lot of internal tools, internal LLM providers, code-related tooling, and many other things that we were not able to share. And with a huge help of the Kotlin folks, like the folks from the Kotlin libraries team, from the Ktor team, and with the help of developer advocates and many other folks from the Kotlin department, we managed to do that before the Kotlin Conf. We extracted a lot from the internal sources, and we actually had to support a lot of the external providers because internally we have the JetBrains AI, which handles all the routing. But outside of JetBrains, people would want to connect to like Anthropic or OpenAI directly. That was not present in Koog by that time. So that was like a huge work happening there. And yeah, I'm really grateful to all the folks who popped up and did all that like last minute fixes that's made Koog possible.
Incredible. All right. Well, this was a really, really lovely chat, and I think we touched on tons of things. We saw that the Koog can like run on a whole bunch of different places. You can also use it in a whole bunch of different domains, and it has an incredible amount of versatility in regards to composition, turning things into tools, calling other agents, having subgraphs, and so on. It's truly incredible. And yeah, it seems that at the end of the day, like, getting started with it is still just a couple of lines of code, and from there you can just go wherever you need to. So how do people go and get started?
Just visit the GitHub, JetBrains/Koog, and there you can find the repository, the dependencies, and even documentation, by the way. So please check it out, and I'm really excited to hear what people are going to be building with that.
All right. Awesome. Well, Vadim, thank you so much for joining us today and for answering so many of the questions in this certainly extended episode on Koog. It was really a pleasure having you here. And of course, a big thank you to everybody who decided to tune in today to our episode and learn a little bit more about these things. I'm sure there's going to be a bunch of folks who are going to be tinkering away with Koog. I'm going to do it like literally as this episode ends. I'm jumping back into IntelliJ, and I'm going to be tinkering away on some Koog code. So that should be exciting. So yeah, thanks again, and hope to see all of you in a future episode. Thanks for tuning in. Have a nice Kotlin. Take care. Bye-bye.